Hello everyone. Today we are going to discuss the concept of parsing. Parsing. What is meant by parsing? In compilation process, compiler first takes the input and it generates machine code. It compiles the source code and it generates a machine code. But this process of compilation can be done in multiple phases. One of its phases, first phase is lexical analysis phase and the second phase is parsing. In lexical analysis phase, stream of input will be taken as the source code will be taken as an input to the lexical analyzer and it will generate stream of tokens. And in syntax analysis phase, that input will be transformed to other form, and that is parse tree. That means parsing is a process of verifying the syntax of the input stream with the help of one grammar. That means parsing is performed at the syntax analysis phase where a stream of tokens is taken as an input which is given from the lexical analyzer, and the parser produces the parse tree for the tokens. While checking the stream of tokens again is the syntax errors, whether the given input is correct or not, it will be verified by the parse tree. And this parsing can be done in two ways. The one is top-down parsing and the second one is bottom-up parsing. What is meant by top-down parsing? What is meant by bottom-up parsing? Means top-down parsing can be done from root to leaf. Parse tree can be constructed from root node to leaf node. And in bottom-up parsing can be done from leaf node to root node. That means a parser is going to construct the parse tree beginning from the bottom and it goes towards the root node. See, the input for the bottom up parser is input string and the output is start symbol. In top down parsing, process starts from start symbol to the leaf nodes. Here it is an example of top down parsing and bottom up parsing. Here in this it is these are the two grammar. This is a grammar and it is having a two production rules, that is S is deriving AAB and A is deriving CDC, and by using these two production rules it is going to derive ACDB. ACDB is a input string which is represented here, ACDB, and it is derived by using these two production. That means initially what is the start symbol? Yes, S is a start symbol, and the production rule of this yes is AAB is derived AAB, and by replacing the production rule of the non-terminal A with the production CD, here A is derived CD. That means the output string, the output that what we got is ACDB. This is a given input string. That means that ACDB is a input string which is parsed by using these production rules. That means this grammar. So we can say that input string is parsed with the help of this grammar. That means this is called as top-down parsing. This process is done from root node to leaf node. And the bottom-up parsing. Bottom-up parsing means this input is reduced to its non-terminal. This input string is taken as an input and one by one character is reduced to its non-terminal, because wherever D is occurred, this D is going to be reduced to its B. See here D is occurred and this D is reduced to B. Or we can say, let us take A is a terminal. Directly A is not produced by any non-terminal here. So B is produced by this A. Here A is a non-terminal and it is producing B. So B is reduced to A. And then again B is reduced to A in the next step. Again B, C is reduced to A. Now, in the same way from leaf to root, the parse tree is constructed from leaves to root, or we can say every terminals will be reduced to its non-terminals and eventually the start symbol will be generated. Okay, this is the representation of the bottom up parsing. In top-down parsing, we have two types of parsing techniques are there, with backtracking and without backtracking. That means with backtracking means whenever right production rule is not used to derive a particular input string, then the alternate production rule will be used. That means we go back to the previous step and the alternate production rule will be used, and that is called as backtracking. And without backtracking, we have this will be not that much efficient. So there is a other parsing, top down parsing technique, that is non without backtracking, and is one example of this without backtracking technique is LL parser. Before discussing this LL parsers, to construct this LL parser, it needs four steps. That is, a grammar should be deterministic, and a grammar should not have left factoring in it. That means to construct any parser, it takes the help of grammar. It takes a grammar and it parses the input string, whether the input string is syntactically correct or not. It will be verified by using that grammar. But to construct LL parser, a grammar should be in some representation. A grammar should be in required notation. That means a grammar should not have left recursion, and a grammar should not have left factoring. That means left factoring means a grammar should be deterministic in nature. A grammar should not be non-deterministic. That I'll explain with one example. Prime requirement of LL1 is a grammar must be no left factoring and no left recursion. And we should compute first of each non-terminal and follow of each non-terminal. The next step is construct the parsing table, and after that implement stack implementation, and by that parse tree will be constructed. But before constructing first and follow, let me explain you first step, that is left factoring. What is mean by left factoring? See, whenever a grammar, for example, let me take one example. A is a non-terminal which is deriving A, B, and A, C. These two are the production rules. Here in this production rule, A is a terminal, starting terminal, and here in this production rule, A is a starting terminal. If in any given input string, if it is going to be derived that terminal A, there is no clarity in choosing which production rule is to be chosen. Either by choosing AA or AC, the string is going to be derived. It is not clear. That means it is not deterministic in nature. Grammar is said to be left factored when it is in the form of A is deriving alpha beta 1, A beta 2, A beta 3, and A beta n, like this. That means all the production starts with the same terminal symbols. So it is difficult to choose which production is to be chosen to derive the given input string. So this left factoring should be eliminated to construct top down parsers. Okay, how we are going to construct this how we are going to remove this left factoring? The equivalent grammar should be written for the left factored grammar. This is a left factored grammar. Okay, and for this grammar, the equivalent grammar will be written by removing the left factoring. Now all the productions are generating the input. All the productions are going to generate the strings which starts with A, right? So I'm going to write the production which starts with A, and to produce beta 1, beta 2, beta 3, beta n, this A dash is a new non-terminal which is used to produce all those terminals in all those set of strings. Now A dash is going to derive beta 1, beta 2, beta 3, and dash dash beta n. So this is a representation or resultant grammar which is not having left factoring in it. Next, the example of left factoring, example to remove the left factoring is here in this grammar. S is deriving AAB, AA, and AB. In this AAA or the all the productions are having or producing same input terminal. I mean, same terminal is going to be derived, that is A. So this is in the form of left factoring. So removing left factoring like this, S is deriving A dash. This A dash is going to derive AB, A, and B. Okay. A dash is going to derive AB, A, and B. And the result in this grammar, there is no left factoring in it, because one production is deriving B and the other production is deriving A. Okay. See, the production rule, yes, is deriving A or AB, then A is going to derive something and B is going to derive some set of strings. Now this grammar is having left factoring in it, because these two productions are deriving the set of strings which starts with A. So there is a confusion in this choosing of these two productions. So yes is going to we are going to remove the left factoring by changing this production rule as yes is deriving A dash, and this A dash is going to derive either A or B, either A or B. So this is about left factoring of a grammar. Next, left recursion. Recursion means a process in which function calls itself directly or indirectly is called recursion, and the corresponding function is called as recursive function. See here, left recursion, there are two types of recursion, that is left recursion and right recursion. Right recursion means a production of grammar is said to have right recursion if the rightmost variable RHS is same as the variable of the LHS. That means here, let us take this production rule. In this, A is the rightmost symbol, rightmost variable, and it is equals to left hand side of the production rule. If a grammar contain right recursion, then it is said to be a right recursive grammar. But there is no problem with the right recursive grammar to construct LL parser, top down parser. And there is a problem with left recursion only. There we are no need to eliminate the right recursion. We should not, it is not necessary to concentrate much on right recursion. Left recursion. Left recursion means if a production rule is in this form, that means leftmost variable in the right hand side of the production is equals to LHS, then this grammar is said to be a left recursive grammar. This grammar is not suitable for constructing top down parse. It is not much useful in top down parsing. We should eliminate left recursion from this grammar. See, let us take this grammar. A is deriving A alpha or beta. Now initially we'll start parsing with A, starting non-terminal. A is going to derive A alpha, again A is going to derive A alpha, again A is going to derive A alpha. See, we don't know when this beta should be used, at which point of time beta should be replaced, A should be replaced by beta. This is a problem in left recursion. A grammar is left recursive if it has a non-terminal A such that there is a derivation called like this. There are two types of recursions, in immediate left recursion, and that is called as direct left recursion or indirect left recursion. Indirect left recursion, when this indirect left recursion is occurred in the sentential forms. Eventually, let us take this example. A is deriving BR. In place of B, if B is producing the product set of strings with CS. In place of B, if I write CS, CSR, and in place of C, if I write ATSR, if I write AT, see, I am going to get the non-terminal A here in the right hand side of the production. That means the resultant production that I got is A is deriving ATSR. So after some derivations, the production which is generated is like this. The production rule which is generated is like that. That means leftmost variable in the right hand side is equals to left hand side of the production rule. This is called as indirect left recursion. So either direct left recursion or indirect left recursion we should eliminate to construct top down parser. How we are going to eliminate, how we are going to eliminate this left recursion? If the grammar is in this form, a is deriving a alpha beta, as I said earlier, a is deriving a alpha beta, so this a and a is same. Here it is given a and a is same, so we can transform this like this. These are the two production rules. These are not having any left recursion. See, let me explain you. A is deriving beta a dash, because in the left recursion a is deriving a alpha, a is deriving a alpha, a is deriving a alpha in the same way, or at last a is deriving beta. That means the set of strings which are generated by using this grammar is beta comma beta alpha comma beta alpha alpha comma beta alpha alpha, like this. That means initially what is the starting terminal, all the input strings are going to be start with beta only, right? So the production is starts with beta, and the new non-terminal a dash. A dash is going to derive alpha a dash. Alpha a dash means the remaining terminals after beta is, here it is epsilon, here in the second string is alpha, here alpha 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 alpha, so on, a number of alpha terminals. Now that can be derived by using this production. Only beta can be used by using this production. A dash is deriving epsilon and a dash deriving alpha a dash. So these two are the two production rules which are used, which are the resultant production rules by eliminating the left recursion from the given grammar. This is a grammar. This is an example production rules. E is deriving E plus T or T. There is a recursion, left recursion in this grammar. We can eliminate this left recursion by E is going to derive here. This is E alpha and this is A and this is beta. Apply transformations to E. How we are going to apply transformations? Beta a dash. If a production rule is in this form, A derives A alpha beta, then the resultant production rules by eliminating left recursion is A is deriving beta A dash and A dash is deriving alpha A dash or epsilon. Here in this, alpha is plus T, A is E and T is beta. Okay, these are the two production rules that are generated by eliminating the left recursion from the given grammar. These two are having left recursion. These two productions are having left recursion and this production is not having the left recursion. So these two are the production rules that we got by removing the left recursion, and these two are the two production rules that by removing the left recursion from this production rule. These are some more examples of left recursive grammar. So to construct LL parser, first of all, a grammar should not have left recursion in it, and a grammar should not have left factoring. That means a grammar should be deterministic in nature. And then we have to compute first and follow of each and every non-terminal. What is mean by first and what is mean by follow? Let us discuss now. During the process of derivation, first and follow will help to choose which production rule is to be applied based on the input symbol. In top down parsing, backtracking in syntax analysis, backtracking is one type of parsing technique in which it is very much difficult to implement. So here, without using backtracking means we should not use improper production rule. It should be used, a proper production rule should be used. That means the correct production rule should be chosen to derive a particular input string. How we are going to choose the correct production rule? It depends on the first and follow of the each and every non-terminal. So to construct the first, to compute the first of all the non-terminals, what is mean by first? Let me discuss first. First is a variable can able to generate sequence of strings. In that sequence of strings, the starting terminal which is generated, all the collection of the starting terminals which are generated by that non-terminal is first of that non-terminal. First is always find out the terminal symbol from the given grammar. When we check out first of any symbol, then if we find any terminal symbol in the first place, then we can take it. Okay, let me explain you. See, S is a starting symbol and it is going to derive B. Let us take this production as some example. And S is going to derive set of strings which starts with a terminal A. Then this A is said to be first of A. First of A. Here it is given A is deriving A, then first of A is equals to A. And if the grammar is in this form, then first of A is equals to A. Then if the grammar is in this form, that means A is deriving AB and also A is deriving epsilon. That means A is going to derive set of strings which starts with A is going to derive set of strings, no set of strings, that means epsilon. Then first of A can be said to be A comma epsilon. And if the grammar is in this form, A is deriving B, C, D. As B is a non-terminal, that should be replaced by another production. That means B is a non-terminal. Further, it is going to be derived, right? So to compute first of A, we should find first of B. B should be replaced by its production rule. So here we are going to get A is deriving ED. That means in place of B, I am writing ED and C, D. So first of A will become E because these set of strings are going to be generated by using this non-terminal. E is a first of A. And also open bracket A. Here in place of B, we are going to replace this second production rule also. So first of A is also consist of open bracket and epsilon. And rules of follow, that means to find follow of any variable. What is mean by follow? In the derivation process, the collection of initial terminals of all the strings is called, of all the strings which follows a variable is called follow of that variable. That means while deriving any input string, the collection of initial terminals of a string. Let us take one string. The initial terminal of that string which follows a variable, is called follow of that variable. Let us take this grammar. It is given A derives B, A, C. This is a terminal symbol and it follows a non-terminal variable A. Then we can say follow of A is C. And also one more thing, in the follow set, if the grammar for the starting symbol of the grammar, we are going to add dollar to the follow set of the starting symbol of the grammar, where yes, if yes is a starting symbol of the grammar, then follow set of yes contains dollar. Here in this grammar, as A is a starting symbol, then follow set of A contains dollar, as well as C, because To compute follow, we are going to check right hand side of the productions. A is followed by this terminal C. This is the first terminal which followed by this A. So follow set of A contains C and dollar. Next, if the grammar is in this form, A derives B A dash. That means A is deriving two non-terminals. See, there is no terminal which is followed by A dash. There is no terminal which is followed by A dash. So, if we want to find that follow of A dash, first of all, we should replace this follow of A dash will be computed. 1 second. If there is no production here, if grammar is in this form, A is deriving B A dash, then there is no symbol, no terminal is following this A dash. Then we can say follow of A dash is equals to follow of A. That means whatever the set of strings which are derived by this BA dash is always going to be derived by this A. Where if A is a starting symbol, then dollar is the symbol which follows us. Where A is a starting symbol, if it is deriving some, let us take ABC, and this ABC is followed by S because this is end of the string. This represents end of the string. This dollar is followed by starting variable, and BA dash is a production rule. In this, A dash is not followed by any terminal, means BA dash is going to derive same set of strings which are generated by A. So whatever the symbols which are followed by A will also followed by A dash. So here we can say follow of A dash is equals to follow of A, and that is equals to A dollar. Now, if a grammar is in this form, when we want to find follow of B here, see to find the follow of B followed by C. But C is not a terminal symbol. C is a non-terminal symbol. So replace this C with its production rules. Now put first of C in the production rule. First of C in the production rule. First of C is star D. That means the resultant production will be B. In place of C, put star D. Okay. Now B is followed by star. That means follow of B is equals to star. Follow of B is equals to star. Sorry. But when the value is epsilon, see first of C is star comma epsilon. If you put star here, then star is a terminal which followed by B. But if we put epsilon here, this C will get vanished. That means follow of B become follow of A, where A is a starting non-terminal, and follow of A is equals to dollar. So follow of B is also contains dollar. If we substitute epsilon in place of C, then follow of B is equals to star comma dollar. Now this is example grammar which is to compute first and follow of the given grammar. See, let us take this grammar. E is deriving TE dash. Each and every non-terminal we are going to compute first and follow. First E. Let us take this E. See, E is a non-terminal which is deriving TE dash, but whereas T is not a terminal. See, T is further, it can be derived some set of strings, that is ft dash. T, we can replace T with ft dash. So E is deriving T E dash. That means we can replace this T. So eventually the production rule will become F T dash E dash. But F is also a non-terminal. We can replace this F with either open bracket E close bracket or ID. See, in place of F, I can replace this production or this production rule. See, if I replace this production rule, opening bracket, opening parenthesis will be the first terminal which is generated, right? And if I replace ID is a terminal symbol and it is a first terminal. The production rule will be like this: ID, T dash and E dash. So ID will become the first terminal uh, which is in the set of strings that are going to be generated by this E. Okay, now what are the first set of E contains now ID comma open bracket. Now next, in the same way, compute first of E dash. So st- E dash is going to derive set of strings which starts with plus. So there is nothing to do furthermore because plus is a terminal symbol which is generated, which is, I mean, it is a starting symbol of the input strings which are generated by this E dash, and also epsilon. Epsilon is also going to be generated by this E dash. So first of E dash contain plus comma epsilon. Next, T is deriving, next for the non-terminal T, we are going to find first. Consider this production, T derives Ft dash. In this, F is going to replaced by either this or this. If I replace F with this production rule, then opening bracket will be the first of that input strings, generated set of input strings. If I replace ID in place of F, then ID will be the first terminal which is generated by this non-terminal. Okay, now first of T contains ID comma opening parenthesis and T dash. Here consider this production T dash. Star is a first of input string which are generated by this T dash, and also epsilon is a terminal which is generated by this T dash. So first set of T dash contains star comma epsilon. And next F. F is a non-terminal and which is going to generate set of strings which are starts with opening bracket and ID. Now let us compute follow for the same grammar. Follow of each and every non-terminal. Follow of E dash, where E dash, follow of E, where E is a starting non-terminal, and follow of E will be the dollar. And also we have E here in this production rule. Check wherever E existed in the right hand side of the productions. So here also E is existed, and this E is followed by closing parenthesis. Now add this closing parenthesis to the follow set of E. To the follow set of E, add closing parenthesis. So what are the symbols, the terminals which are in the follow set of E is dollar comma closing parenthesis. Now compute follow for E dash. For E dash, in the first production, E dash is not followed by any terminal. That means follow of E dash will become follow of E. Follow of E means dollar comma closing bracket. And also here in this also E dash is existed, but here there is no terminal is followed by E dash. That means follow of E dash will be same as follow of E dash. Now follow of E dash will be the dollar and closing parenthesis. Now let us compute follow for T. T is deriving F T dash, check whether T is existed in the right hand side of the productions or not. Yes, it is. T is existed in the first production and in the second production, but T is followed by E dash. Now compute first of E dash. Here also first of E dash. By computing first of E dash, we can able to find the follow of T. First of E dash is plus comma epsilon. If I replace plus here, that means T is followed by plus. That's okay. But follow set doesn't contain epsilon. If I replace epsilon here, if I replace epsilon here, then T is not followed by any terminal. Then follow of T becomes follow of E. So follow of T will become dollar closing bracket and plus. Next, follow of T dash. Here T dash is existed in the production rule. T dash derives star F T dash slash epsilon. That means T dash is followed by nothing. And also here also one more production rule is there. T is deriving F T dash. Here T dash is also not followed by anything. That means follow of T dash will become follow of T. Whereas follow of T is dollar closing bracket closing parenthesis and plus. Here dollar closing parenthesis and plus will be included. At the same time here follow of T dash is again follow of T dash. Now follow of F. The last symbol is follow of F. F. F is existed in the production rule. T is deriving F T dash and T dash is deriving star F T dash. Here F is followed by T dash and here F is followed by T dash. That means first of T dash will become the follow of T. First of T dash is star. If I put star ft dash in place of t dash, then star will be the symbol which is followed by f. And here, if t dash is replaced by the same production rule star ft dash, then star will be the terminal which is followed by f. And in the same way, T dash is going to derive epsilon also. T dash is going to derive epsilon. If I replace epsilon in place of T dash, then follow of F becomes follow of T, because F is not going to be followed by any terminal. So follow of F is become follow of T. And here follow of T is computed and it is dollar closing parenthesis and plus. In addition to that, we computed star as a terminal which is followed by F. Now follow of F contains dollar closing parenthesis closing bracket plus and star. This is how we are going to construct follow of a given grammar. And by to construct LL parser, we have to remove left recursion in the grammar, and we have to make the grammar in a deterministic way. That means we should remove left factoring and then compute first and follow of each and every non-terminal, so that construction of the LL parser will be possible. In the next video, we'll discuss about the construction of the LL parser. Thank you.